to all. I'm Hon, and now we are going to introduce what is all about this PBL. So we all know that the traditional analog communication system is using the amplitude, frequency, or phase modulation has been gradually replaced by more advanced system, which is the digital communication system in recent years. So the digital communication system outperform analog system in terms of processing speed, multiplexing, and also the noise immunity. So technically, digital communication include the digital transmission and also the digital radios. So digital transmission is the exchange of the digital pulse between 2 points in a communication system. So between the transmission and receiver, a physical facility such as the metallic wire pair, the cord cable, and also the fiber optic cable is required for this process. And then for the digital radio transmission, is used in the open space and also the Earth atmosphere. So in the digital communication, we have four most common pulse modulation method. The first one is the pulse width modulation, the pulse position modulation, the third one is the pulse amplitude modulation, and the last one is the pulse chord modulation (PCM), which is this is the modulation that most extensive use technical for digitizing information signals for electronic data transfer. So this is the common PCM system block diagram. So we have the input, and then firstly we're going through the bandpass filter, which is used to reduce the incoming analog signal to the voice band frequency range. So after this, we're going through the sample and hold circuit, which is used to sample the input and convert them to the multi-layer PAN signal. So PAN signal is somehow like this. So after this, we're going through the analog to digital converter. So it's actually to convert the PAN sample to the serial binary data stream ADC. So it becomes the PCM sample. So the receiving DNA converts the serial binary data string to a multi-layer PAN signal as previous, and then we're going through the digital to analog converter to make the PAN convert back. So after this, we also go through the sample and hold circuit, and also the last one is the low pass filter to return the PNS system to its original analog form. So that is the operation of the PCM system. So this is our filler table for using in this PBL. So first, we got the fact that the PCM technique is to analyze the complex problem of the digital communication, which is the digital modulation and also the transmission. So we got the idea that the PCM is actually to affect the digital modulation and transmission, but we got to analyze how does PCM affect so by solving this problem, we actually going to do the research online and also analyze through simulation, which is in this case we use the MATLAB Simulink regarding the digital modulation and transmission. So the second fact, we know that the PCM system characteristic can be analyzed under different type of scenario. So we found out that the different specification and limitation for the sampling rate and also the sampling bit will produce various PCN signal and for the PCN encoding and decoding system. So in this PBL, we're going to find out what is the output can be analyzed for the different type of scenario. So for this, we proceed to simulation that can obtain users the range of the specification and also the limitation to analyze the PCN signal. So the third one, we got the fact that the modulating signal can be recovered with the similar or the same analog modulating signal at the receiving output. So we found out the idea that it is actually can be recovered by a certain technical. So we have to find out what is the suitable solution that will produce the similar analog modulating signal. So we also trying to research online and analyze through simulation to find out what is the solution. So and then after this we also know that from the PBL we can do an iterative simulation electronic communication system for education purpose. So this is to aim that the student can understand the digital modulation and also transmission. And then we're going to find out what is the knowledge about the digital modulation and transmission by using MATLAB simulation. So therefore we're going through the MATLAB simulation. So the last fact we're going to know that is to learn more about the digital communication, but we find out that we have lack of experience and knowledge about digital modulation and transition. So we're going to find out why is it important by doing any paper review and on journal about this topic. So that is all for the filler table.
Assalamualaikum and hi, my name is Noaina binti Kamara Arifin and the method number is E10009. So for the fishbone diagram, the problem solving for this PBL2 is me will present the diagram. So first is the communication, start with meeting, then dividing tasks, explanation on PBL and meet the requirements. So next is for the future process, unclear expectations, and then research. Second is for the processes. We define the PBL characteristic, research for the PBL, run the simulation, report writing, and inconsistent application, which is like we use the Simulink. Then repeat the simulation, research again, discussing as the output. So third is simulation. We build the block diagram, the exact block diagram. Then non-value added work, manual calculation, simulation performance, and result focus. So next is the report writing, data analysis, identify complex design issues, and then meet the requirements. So for the configuration selection is first the requirements needed. We define the output and the simulation, the regulation phase for our group. Then we repeat the simulation, then research again about the PCM. For the build time, first is the report writing, result focus, complex flexible, complex and flexible simulation, mistakes not tolerated, which is the manual calculation and the simulation. Then we find the desired manual calculation, the desired simulation, the desired output, and decision making. The last is for the submission. We proceed to the final report, presentation, final output, discussion, and systemic problems uncorrected, which is the for the report. And then for the final report, start doing the video presentation, show the desired output, and show the desired simulation. So that's all for me. Thank you.
Assalamualaikum and hi, my name is Nur Aini Nadra binti Kamal Arifin and my project number is CE10049. So for this problem-based learning PBL2, which I will show the simulation and its output for part A, which the sampling for MT is the minimum required according to Nyquist, the scenario 1 and the scenario 2. So first for the scenario 1, for the 4 bits encoded PCM. So for the sampling frequency is Fs equal to Fm equal to 2 times by 100 equal to 200 Hz. And for the bit rate is SR times 6. The value of SR is for the 200 times 4 equal to 800 bps. The bandwidth is equal to the bit rate is 800 Hz. So for the simulation, this is our block diagram for the 4-bit PCM. So for the sampling pulse, we set the amplitude 5 and the period seconds is 1/3200. The pulse width is 5. For the modulating signal MT, amplitude is 5. Frequency is 2 times 5 times by 100. Then we run the simulation. First, we show the output at the oscilloscope. So as you can see, there is 2 sine wave here. So for the scenario 1, the blue sine is MT and the yellow is for M prime T. So next is for the scope, output for the scope. For the 4-bit encoded PCM display, so for the MTs that we set 5 for the amplitude and for the S is 5 also. So that's it for the 4-bit encoded PCM. So next we move to the 8-bit encoded PCM. So next for scenario 2, the sampling frequency Fs is the same as 4 bits encoded PCM data, but for the bit rate is different as we need to times by 8, so we get 1600 bps and the bandwidth is 1600 Hz. So for the simulation, this is our simulation, the block diagram. For the sampling pulse, we set the amplitude 5, period seconds 1/3200. The pulse with percent of period is 5. So for the modulating signal, it should be 5. The frequency is the same. Then we could run for the oscilloscope output. This is for the MT and this is for the M prime T. So for the output, 8-bit encoded PCM display at the scope. So this is the output for our simulation. This is for bit 8, then it's bit 8, this is 5, 6, and 7. And this is the encoder. the modulating signal. So that's all from me. Thank you.
Hi, and a very good day. My name is Zhongxin Min, matrix number CE190008. So for this PBL2, I'm going to explain about part B, which is the sampling for MT is more than required according to quiz. So which is the scenario 3 and 4 is the value of frequency much more than the sampling frequency. So now as you can see here, the slide here, there is the 4-bit encoded PCM output waveform for scenario 3. For scenario 3, the sampling frequency is we define as 3200 Hz since fs is more than 2 FM is required and the 4-bit encoded PCM data is applied. So the calculation here is the BR, which is the bandwidth, is equal to SR times N equal to 3,200 times 4, which is 12,800 bps. The bandwidth is 12,800 hertz lah. So this is the output for the PCM from the PCM output waveform from scenario 3. And then this is the oscilloscope output for scenario 3 also. And then next one is the 8-bit encoded. So as you can see here, this is the PCM output from the scenario 4, and then this is the oscilloscope output for scenario 4 also. For scenario 4, the sampling frequency is same as the previously, same as the 4-bit encoded PCM, 3,200 Hz. Then the 8-bit encoded PCM data is applied. Then the calculation here is we are equal to 302,000 times 8, which is 25,600 bps is equal to 25,600 Hz. This is the actual block diagram that we do. So the pulse signal here, the setting here is this amplitude 5, and then the pulse width is 5, and then the period is 1 per 3,200. And for the modulating signal setting, the parameter here is the amplitude is 5 and the frequency is 2 times 5 times 100. Then for the bit converter, since this is the 4-bit and then we put 4-bit here, bit integer is also 4-bit. If there is the 8-bit here, 8-bit, so this is the block diagram as 8-bit, I do it separately. And then we only need to change the parameter here for the numbers of bits. Then also the parameter for the pulse generator is all the same. Then now we will see the output for the 4-bit. The actual output here is like this. This is the output for the encoder, and then the second one is for the sample and hold, and then modulating signal is here the number 3 waveform. So this waveform is for the 4-bit encoded. Then the oscilloscope here, this is the oscilloscope waveform for the 4-bit. Then now we will see the output for the 8-bit encoder. So this is the output for the 8-bit encoded as I shown in the slide previously. The first one is the encoder, and then followed by the sampler and hold modulating signal, and the bit number 8, number 7, 6, and 5, and then followed by the bit number 4, 3, 2, and then the LSB. So that's all from my part. Thank you.
Hello, Assalamualaikum. My name is Syamil Bakri Ibrahim. My metric card is CE190170. So today I would like to explain about the simulation for PBL2. So my part is I'm going to do for this part C, which is require us to do like sampling for MT is lower than minimum required according to Nyquist. Okay, so I'm going to continue for this block diagram. So the block diagram I already draw for my part. So As you can see, we can see the sampling pulse signal for Fs is, wait, okay, so the amplitude that we use is 5. So the period second, it should be period second is 3200 second, but we need to lower the minimum for this part, which is I use 1 per 100 second. So the pulse width is 5% of period, and the phase delay is 0 second. Okay. So the modulating signal for MT, so the amplitude that we use is 5, and the bias is 0. The frequency is still the same, 2 times pi times 100 rad per second. For the phase rad 0, sample time is 0. Okay, so I'm going to show you the output for this 4-bit encoded PCM display. So before I show you, we need to run first. Okay, after we run, we double click this scope. Okay, it already stated the result here, which is encoder, sample and hold 1, modulating signal MT, bit 4, bit 3, bit 2, and LSB. So this is the graph for the encoder. Okay, and then this is the sample and hold 1 for the output. For the output for this modulating signal is here, and the bit 4, bit 3, bit 2, and LSB is here. Okay, so that's all for my part for this part C. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rizwan Shakir bin Muhammad Hamzani. My matrix number is CE190085. So I will present to you for part D. So on the first slide, we can see that we have VM equal to 15 volts, and this is the 4 bits encoded PCM. So this is the output waveform. So for scenario 3, VM equal to 15 volt, Fs equal to 3200 Hz. So the second one is the oscilloscope output for scenario 3. For the blue graph, MT. For the yellow graph is M squared T. So next slide. So this is for 8 bits encoded PCM output waveform for scenario 4. So we have VM equal to 15 volt, 8 bits encoded PCM. So we have Fs equal to 3200 Hz. So this one, the second one is the oscilloscope output for scenario 4. As you can see, the blue graph is M in the bracket of T, and the yellow graph is M equal in the bracket of T. So the next one is the 4 bits encoded PCM. VM, we have 0.5 volt, and Fs equal to 3200 Hz. So this is the output waveform for scenario 3 for 4 bits encoded PCM. So this is the oscilloscope output for scenario 3. So for the last one, we have the VM equal to 0.5 volt, and we have 8 bits encoded PCM output waveform for scenario 4. So as you can see here, we got VM equal to 0.5 volt and Fs equal to 3200 Hz. So the second one is the oscilloscope output for scenario 4. The blue graph is MT and the yellow graph is M squared T. So I think that's all from me. Thank you. Assalamualaikum.
And now we're going to do the simulation for part E. So the part E is all about, based on the part D, we have to make the suggestion to make sure that the resultant recovered signal, the M prime T, is same or similar to the modulating signal MT by changing the setting of the block diagram and or add additional block diagram if necessary. So now we will try to do the simulation based on the part D1. So part D1, the VM is 15 volt. So for the FF block, the amplitude is 15, and then the period is 1/3200 second, since Fs is equals to 3200 hertz. And then for the MT, the amplitude is 15 volt. And then previously the peak is set to 5 for both encoder and also the decoder. So we're going to change the peak value to the same with the amplitude of the MT, which is the Vn. So it is 15. And then for the decoder, we also change it to 15 for the peak. And then now we're going to run the simulation. We click on the oscilloscope, and this is the result. So I will enlarge them to see the clearer picture. So we can see that the blue graph is represent the MT, and then the yellow graph is M prime T. So we can see that the output is actually similar to the input, since there are the sine graph. So this is all about the simulation part. And now we are trying to do the simulation based on the part D2, which is, in this case, the Vn is 0.5, and also for the amplitude of the Fs, we change it to 0.5. And then this time we change the encoder, the peak is also to 0.5, and then peak for the decoder 0.5, and then we run the simulation. So made an enlarge. So we can see that the output graph is similar to the MT, because they look just as a the sine graph. So that's all from me.
So as a conclusion, for this PBL number 2, so the PCM encoding and decoding has been successfully developed and being created by using MATLAB simulating software. So the development of this PCM encoding and decoding is important to give a clearer understanding for students. So this simulation and also can be used for as an educational tool for lecturer and to attract the student to enjoy learning and relate it to theoretical perspective of electronic communication system. The visualization used in this interactive education simulation will allow a better understanding on the PCM encoding and decoding. Through this simulation, user will understand easily the process of the waveform display from one and another. So that's all from our group. Thank you so much.